Good evening, my warriors. Welcome aboard to the fourth session of Magnetic Sources and Effects chapter. Now, if you are a lover of electric cars and if you have heard about electric cars, you know that electric cars do not have engines, but in fact, they have motors. So guess what? The motor rotates the wheel based on the principle that we are going to study in today's chapter. We are going to see how a torque is created, and we are going to see how a current carrying wire actually experiences a force, and we are going to solve problems on this. So all of this with me, Shreyas, your physics master teacher at Vedantu. Vanakkam. Good evening. Hello PL, Windbone, Paprazo, Venkata. Welcome aboard Munna Bhai. Welcome Vikram. Welcome Boli Bunya Ruchita. My God, nice name. Hi Ankit. Hi VSK. Hi Sachidandan. Hi Nitish. Welcome. Good evening. This is Shreyas, your physics master teacher, and I not only teach on Vedantu YouTube channel, but also I teach on the regular platform where you can find a lot of micro courses of mine. In fact, I have made a special video on that as well a few days back. So you can check out all the micro courses that I'm taking up, and you can watch those sessions as well. If you're a pro member, you can watch it all for free. And I am here on YouTube so that I can spread the joy of learning, so that you guys love physics, so that anytime you need help, there is always a person out here on YouTube to help you. And this is an English medium channel, and not many out there are actually teaching in English. So we decided to do this, and thank you guys for all your love and support, because of which we have grown to 52k subscribers, and we will keep growing, and you will also keep growing. Do not forget to smash the like button and hit the subscribe button before we go ahead. Thank you guys very much for all your love and support. All right, so no VSK, I just had a haircut today. Hi Sachinan, I'm very good. Welcome everyone. This is theory wise, yes, the last lecture PL, but tomorrow we are going to have an advanced session, and that's what you're going to see. By the way, tomorrow morning at 9 o'clock, that's the session for you as well as the 2021 students. That's the entire 11th standard syllabus mock test. So do not forget to check it out. And that's for both JEE Mains as well as BITSAT. And guess what? On Thursday, logical reasoning, because you guys wanted, sir, what kind of questions are asked? So I am going to give you lots of questions on logical reasoning of bits for BITSAT. And tomorrow 7:30, do not forget, that's advanced questions on magnetic effects and sources. So the entire chapter in a way will be revised more thoroughly, and we are going to see much deeper concepts and tougher questions tomorrow. And the rest of the sessions, the ones in red, are for the 11th standard guys, and the 11th standard kids are going to complete the chapter of 2D and going to have advanced sessions, you know, after the chapter, and a special session for you guys on Saturday. So guys, aren't you loving this? Having, you know, normal sessions and then scaling it up with advanced session and then Menti quizzes. So guys, if you're loving this method, if you're loving and if you want to support this way of teaching, please come on, go ahead, recommend this channel, and also hit the like button and tell everyone that Shreyas sir is teaching for all of you. The entire long-term series is being done on YouTube. What more you want? So these are the long-term courses, plus you are having the mock tests, etc. for the 2021 batch. Now remember guys, if you want to actually join Vedantu, then I will give you even more reasons why you should join. The number one reason should be VIP, because Vedantu is giving you a promise that you guys are going to improve from the time you join Vedantu till the time you actually graduate from Vedantu. And this is an assurance, this is a guarantee. So if by chance, let's say you do not improve, then the entire fees are refunded. So the reason for this confidence is because of the amazing ranks we have been producing, and lot of changes are happening in Vedantu, lot of new technologies, artificial intelligence behind the scenes, the way in which we grade students, the way in which we analyze students, the way in which this data is used to do better for the students, parent-teacher meetings, the Tattva hard copy material, the doubt solving, the test analysis, the reports, all of this make sure that students who study under us are performing far better than the students who are studying in any offline or even online coaching institutes. You can see the results are here for you, and if you are interested in joining any of the subscription plans, I have mentioned it here. There is also a link which is there in the description box below. Go ahead, check it out. All the details are mentioned very carefully. Watch it, read it, and then use the coupon code SHHPRO to get 10% off. Alright, so let's begin with our class today. And thank you, Nitish. What's the pro subscription code, Vishwa? It's SHHPRO to get 10% off. And also, when you use the code, if any problem happens during the admission or during the course also, you can directly contact me because you have used my code. I can get in touch and I can escalate any of the issues that you face directly with the admins or the authority. So all your issues get resolved. So that's the advantage of using my code apart from getting discounts. Yes, welcome. I have visited Chennai many times. I have visited the IIT Madras campus. I have participated in the Tech Fest. And I have gone to the beaches out there. I have had those nice fishes also which they fry on the beach, and it's very nice. It's beautiful city. I have been there many times. Venkata, right now I have not yet planned, but in a week or two I am going to plan, Venkata, for 12th standard also marathon. Thank you, Sonu, very much. Thank you, Kaushik. Like this only, you keep loving, keep supporting. Trust me, I'll also love you unconditionally, and I'll also support you and make sure that you guys grow. Okay, so let's get going. Now, we have seen that a charge which moves in a magnetic field will experience a force, and that force is given by F is equal to charge into velocity cross product the magnetic field. This was the force. A stationary charge will not experience force. Only the velocity perpendicular to the magnetic field experiences force. That's what we have seen. I've seen so many cases also of that in the previous class. In case you missed it, do not forget to check out our previous lecture. It's just there over here. All you need to do is go to our channel, very easy. Go to playlists out here, and just when you go a little bit down, you will see the physics playlist. Just click on that and you will see all the chapters are arranged beautifully, and these are the ones for 11th standard. Units and dimensions. You can see the name of the chapter itself. Like here, electrostatics, Gauss, current, capacitors, magnetic. This is for 12th standard. Click on any of the playlists out here, and that's it. You can see below over here all the lectures are arranged. So today is the 4th class. You can see the 3rd and the other classes as well. And we can also see who and all have done the homework last time. You can see Vikram has done the homework, Aishwarya has done the homework, Srivatsan, very good. Very good. Oh, Rahul just has some nice things to say for me. Thank you, Rahul. Chemistry lover. Wow, because of me, you are able to give 8 questions in mocks. Very good, chemistry lover. Paparazzo, and then Unknown Krish and Apurv. Okay, chalo. Thank you guys, and keep posting your answers like this. We'll keep showcasing all those students who are, writing the answers down. Now, think about it. Thank you, Arun. Hello, Tanushri. Welcome aboard. Hello, everyone. See, just because a moving charge can experience force, what is current? Current is also motion of charges. Yes, I agree, the protons or the nuclei do not move, the electrons move. So even those electrons which are moving in a current carrying wire, and if it is placed in a magnetic field, shouldn't that also experience force? That's the whole idea behind a wire which carries current also experiences force. If a moving charge can experience force, a wire carrying current also has moving charges, and that's the reason why it will experience force. Now the formula for that. Okay. Oh, unknowingly? I don't know. Maybe. It's okay. Now, the force on the current carrying wire is given by, look at this. This is a wire of length L. Current flowing in it is, let's say, I, then the force acting on it is given by the current multiplied by the length cross the magnetic field vector. So this is the formula for the force acting on the wire due to the magnetic field. Now you might be wondering, sir, L is length. Now what direction should I take the length? Now isn't it obvious, guys? The direction of the length vector is same as the direction of the current. So for example, in this situation, length vector is there because current is flowing towards your right side. So length is there, magnetic field is inside. Use your right hand, everybody, come on, use your right hand. Take your right hand, first put your 4 fingers in the direction of L. It's in the direction of current. Remember, it's there. Then slightly move it towards B, which is inside. L and then B. Where is your thumb coming? It's coming that way. So hence the force acting on it will be over here. Is that clear, everyone? Similarly, understand if the direction of current reverses, let's say the current was going this way, then you have to place your 4 fingers like this, but magnetic field is inside. I cannot move it like that. Remember, always move your fingers as you curl your hand. So do not do L cross B, that will be stupidity. So you have to move your hand like this, twist your hand like this. This is L, L is that way towards your left, cross B. Now the force will be downwards. So on a wire which carries current towards your left side, the force will be downwards. That's how it works, as simple as that. Glad to know that, Arun. I'm pretty sure if you keep watching my lectures in JEE Mains also, you will score lots and lots of marks, trust me. Okay, so thank you. And yeah, so that's the answer. So you just use right hand rule. Now, remember, so Sai Lakshman, this is the 4th lecture. One more lecture tomorrow on advanced. Understand one thing, lot of students try to remember this using I, L, B and that force, F, L, B, F, I, B, and then they don't remember, was it for left hand, was it for right hand, and then again in the next chapter, EMI, there is B, L, B, then Q, V, B, then torque is I, R cross F is tau. Guys, your hand will just be decorated like a mehendi if you start doing all those things. So please do not do that. Okay, so do not do that. Just remember the cross rule. Always use your right hand. 4 fingers first, pointing towards the first vector, then the next vector. The thumb automatically points towards A cross B. So Ankit, Lorentz force is nothing but magnetic force plus your electric force, both together. So whenever electric field and magnetic field both are there, consider each effect independently. First think what is happening because of electric field, then think what is happening because of magnetic field, then superimpose both of them. That's how it is. In fact, tomorrow we are going to have some more questions on that as well. Okay, now having said that, look at this, see if you are able to visualize. If the current was going towards the left side, you can see the magnetic field is going inside the plane of the board. Look at that, the magnetic field is going from North Pole to the South Pole. So L is towards your left, current is towards your left, B is inside, you can see the force is going to act downwards. So any current carrying wire experiences a pull, which is IL cross B. Let's see whether we can solve this question. Yep, Dhanya, you can watch it for NEET Bacha because the physics part is same. Yes, the questions might be of slightly higher difficulty during the advanced sessions, but mains pattern and NEET pattern roughly the same. Roughly. JEE Mains is slightly more difficult, but roughly the same. Okay, let's get going to the question. A current of 3 amperes flowing in a conductor having length 40 centimeters. The conductor is placed in the field of 500 Gauss. It's a unit. It's not SI though. Makes an angle 30 with the direction of the field. Find the force acting on it. Okay, so let's see what is exactly happening. There is a wire which carries current of 3 amperes and there is magnetic field. Okay, and the magnetic field makes an angle of 30 degrees. Okay, so the magnetic field is making an angle of 30 degrees. Now that's 500 Gauss. Now I don't know whether you know this. 1 Gauss is 10 to the power minus 4 Tesla. Oh, who said that? Jagdishwaran? Very good. Yes, so this is actually 500 into 10 to the power minus 4 Tesla. That's something which you should know. This is 30 degrees. Now just use the formula which I just gave you. F is I L cross B, but that was vector. In magnitude, it's I L B sine theta. What is current? 3. What is length? Is that given? 40 centimeters, that means 0.4 meters, into B, it's 500 into 10 to the power minus 4 into sine 30, which is half. Sine of 30 is half. Okay, so you can write it as 3 4s are 12. 12 into 5 divided by 2, and you see what and all you will get. So you will have 0.4, that means 10 to the power minus 1, 10 to the power 2, 10 to the power minus 4. Now check this out, guys. This will become 6, 6 5s are 30, 30 into 10 to the power minus 10 to the power 1, 10 to the power minus 3. Okay, so this is going to be 0.03 Newton. That's the answer. How many of you got it? Oh, Sonu said 3. No, 3 is not the answer, 0.02. Prashant, welcome aboard. And do not forget to smash the like button as well as the subscribe button so that you do not miss any of the lectures ahead. So we just started with the lecture 4 of magnetism. Okay, beautiful. Yes, 0.03. Yeah. Understood? Clear? Shall we get going? Okay. Roshni Jacob, Bitside mock test is there tomorrow, bacha. Just check out the upcoming live streams. And please check out, guys, our Telegram channel as well as the community posts that we make. I have put up the entire schedule of the week. So please check it out. Please don't keep asking me, sir, when is the next class? When is the other class? I keep posting all the things in the Telegram channel as well as in the community post. Okay, so let's get going to the next question. Now, this is a very conceptual question. Many people are going to make a mistake. Multiple options may be correct. More than one may be correct. This is advanced type of question. Consider a wire carrying steady current and it is placed in uniform field B perpendicular to its length. Okay, so basically imagine there is a wire and it is placed, okay, it's carrying some current and it is placed perpendicular to the magnetic field. Okay, magnetic field is perpendicular. Consider the charges inside the wire. It is known magnetic forces do not do work. We know this fact because F is Q V cross B. It's always perpendicular. Okay, so the question is, which of the following are correct? Read the options carefully. Welcome aboard, free green screen. All right. Yes, there is a link, Roshni. You can check it out. If you visit any of our videos, you will always see there is a link for joining the Telegram link, or check the previous videos if it is not there in the current video, maybe some 1 month old video or 2 months old video. Okay, come on, my warriors. Sonu says B and D. Okay, I don't know. Yes, Kukup, Sukute, when I solve it's easy, and that's how it should be. Every time a teacher solves, it should generally look easier than what the actual difficulty is. And in the exam, even an easy problem looks very difficult. That's the problem. Okay, only D says Windbone. Bem says B. Windbone again now changing to A and D. Interesting. Now I'll tell you what. The motion of the charges inside the conductor is unaffected by B since they do not absorb energy. Now this is wrong. See, they do not absorb energy, that's correct. But the motion is unaffected, that is wrong. Reason, because of this force, the electrons which are moving, they will deflect. Understand, they will deflect because of that force which is perpendicular to velocity. So the motion is unaffected, wrong. Speed might not change because kinetic energy will not change because work will not be done. Now, what happens next is some charges inside the wire move to the surface as a result of the magnetic field. This looks correct to me because of that magnetic field. What will happen? First of all, understand the electrons will be moving towards left side. Electrons are moving towards left side because current is going towards the right side. Use this formula QV cross B. Velocity left, magnetic field inside, V cross B is down, but it is a negative charge, so flip it. So the force on it is here, so you will see negative charges accumulated here and positive charges getting exposed because those electrons are getting a force in this direction. So you will see some charges will move to one surface and other charges will be left on the other surface. That's how it works. Is that clear? Everyone understanding what has just happened? So the current moving there, electrons moving here. V cross B down, but it's a negative charge. So force is up. So those electrons will get a force in the upward direction, so they will get accumulated on the one side. Next up, what will happen is that if the wire moves under the influence of B, work is done by the force. Now understand, see, Munna, I just said that. I just repeated the same thing again. Okay, I just repeated point B, that electron is going here, V cross B is down, because it's negative, force is up. So the electrons will get pushed up, so they will get accumulated on one surface. That's all. Okay. Now, third point, if the wire moves under the influence of B, work done by the force is there. This is wrong. Remember, this statement itself is given. It is known that magnetic forces do not do work. Reason for that, velocity is perpendicular to the force. And remember, work is force dot displacement. The dot product will be 0 because force and displacement will be perpendicular. Cos 90 is 0. Hence, that's why the answer C will be wrong. If this is clear, can we go ahead? Now the last option. If the wire moves under the influence of the magnetic field, no work is done by the magnetic force on the ions, assuming fixed with the wire. Yes, this is anyways true. Magnetic force will never do work because the velocity and force are perpendicular. The same reason is applicable here, and anyways these positive ions will stay there as it is. Only the electrons will get deflected. They will get deflected like this. Okay, so this is the correct option. Is that clear? Everybody understood this? How many of you loved this question because it was a deep conceptual advanced type of question? Two options were correct. Okay, so this is also correct, this is also correct, B and D. Good question, loved it. So these kind of conceptual questions will come in advanced examination, understand? Okay, let's get going. Yeah, B and D, that's correct. Thank you guys. Erwin, probably I will respond to you if you post a comment later on after the video ends. But during the live session, probably my mindset is to teach. Maybe you can ask me later on. Now this is very interesting property. This is very interesting property. This will help you save a lot of time and avoid integration unnecessarily. What it says is that if you have a curved wire, okay, if you have a curved wire, then on every small part of that curved wire, okay, you might see there is a force IL cross B. Okay, IL cross B, maybe, I don't know, maybe like this. And that force may be DF. Again, another small part might experience DF force here. Another small part might experience force here. This part will experience force here. This small part will experience force here. This small part will experience force like this. This part will experience force like this. So each part is experiencing DF, DF, DF force. Now, in order to find the net force on the curved wire, you have to basically add all the small DFs. And guess what? If you want to just add, see guys, ILB, that's the force acting on the current carrying wire. Everybody agrees? So any part of that wire, this is a wire, if you take any part of it, what will happen? There will be a small force DF. This is the small force on an element. So the total force on that curved wire will be addition, vector addition of all those DF bar plus DF bar plus DF bar, addition of all those things vectorially. The best part is you can avoid that integration and just think about it, what you can do about it. I'll just tell you, DF is actually I dl cross B because it's acting on an element. Understand, this is acting on that element dl. I is constant, B is constant, both go outside the integral, so it will look like this. I dl cross b, this is inside, this is outside. B is constant, it's uniform. I is constant, it comes outside the integral. Now what is the meaning of dl vectors integral? dl vectors integral means, understand, dl bar plus dl bar plus dl bar, it's like law of polygon of vectors. It's like this: dl vector, 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 dl vector. Law of polygon of vectors. We can replace it with one single vector starting from the end to the other end. It's one single vector. So I might as well replace it with just I L cross B. That means this statement is true. The force acting on a curved wire is same as due to a straight portion of the wire joining the same two ends with the same current. This is very, very important. But please remember, this is only true if B is uniform. Magnetic field is uniform. Why B is uniform? Because otherwise you will not be able to take magnetic field outside the integral. It will remain inside. So we have taken it outside only because it was constant. So this theorem is only applicable when it is inside a uniform magnetic field. Is that clear? Everybody understood this? Yeah. Oh, don't worry, Vijay Kumar, just push yourself and try to come up and catch up to the current lecture. Oh, Vulcan. Oh, I understood. You are that, I think, what is that? Soviet of Russia kind of guy. Yeah. All right. So remember this theorem, very important. Now the second part of the theorem is also very important, and this is nothing but, if you have a wire which is joined from end to end, that means it becomes a loop. If you have a wire which is like a loop, then what is the effective length between the two ends? See guys, if you had a curved wire, you used to replace it with a straight wire. If you again have a curved wire, you replace it with a straight wire. If you have a closed loop, what will you replace it with? Nothing. So L effective will be 0. That means the force on it will be also 0. So that's the very simple answer. Okay, so a uniform field which is there will apply 0 force on any loop oriented in any fashion. Any loop, remember, oriented in any goddamn fashion will experience 0 force. That's very important. So let's see whether you can solve this question based on those theorems that you just have studied. A semicircular current loop is placed in an uniform magnetic field of 1 Tesla as shown in the figure. If the radius of the loop is 1 meter, the magnetic force on the loop is. Oh my God, Sunita, you're from USA. We have kids from Africa. We have kids now from Nepal. We have kids now from Australia and now also from US. Very good. Yes, Alia, it's 0. Correcto. Windbone says A. Siddheshwar says 4. Aishwarya also says A. Munnabai says A. Thank you, Kaushik. Yep. Hello, Steve. Welcome aboard. Mechanical properties. We have done it in the flash series, but in this long-term batch, it's a long way ahead. It will come later on. If you want to watch it, you can watch it from the flash series as well. All right, Vulcan, always. Okay, Dutch, you can watch thermal properties of matter from the flash series. I have already done it, but if you want to wait and watch it properly, so you need to probably wait for few months till I come to thermal properties in the long-term series. Okay, so just replace this with a straight wire. Replace this curved wire with a straight wire. Now the length effectively will be nothing but the radius was how much? It was 1 meter, right? So obviously the length will be 2 meters. So that force will be I L effective into B. So I is, where is the current? Where is the current? Where is the current? Yeah, 2 amperes. Okay, 2 amperes multiplied by length effective, that's also 2 meters. Magnetic field, that's 1 Tesla. Okay, 1 Tesla. So 2 into 2, 4 Newton. By the way, I should also put sine 90. Reason is magnetic field is inside, length is right way. So both of them are actually perpendicular. So sine 90 is anyways 1. So option A is correct. Beautiful guys, most of you got it correctly. Excellent. Let's see whether you can solve the next question coming up on your screen. Job Cherian. I don't remember. But if you come regularly, probably I'll remember your name. Okay. Aryan, how about this? I'll reply to your comment later on the comment section. Okay, just put up a comment, and if I've missed any of the comments in the previous videos, don't worry. It takes some time for me to reply to all the comments out there. Okay, just hold on. Okay. Come on, my warriors, think about it. C was not the answer, by the way. Okay, hello Yamala, Riya Lakshmi, welcome aboard. Let's see if you can get this. There is a triangular loop, and AB is the direction in which the magnetic field exists. The magnetic field is in the direction of AB. The question is, if on BC, on side BC, the force is F bar, then on AC, what's the force? Okay, figure this out. This is a current carrying closed loop. Very interesting question coming up on your screen. Let's see. Sonu says minus F, which is option B. Harsha says D, which is root 2F. Job Cherian, I will answer your questions later on, not during the class, because it's not relevant to the current topic we are studying. Put up a comment, I'll definitely reply to you. Windbone says root 2F. Sonu saying option B. Ruchita saying A. Bhagya, hello, welcome aboard. Hi Trimbak. Vulcan also saying minus F. Ruchita saying A. Kup saying no idea. Yamla saying haath jod diye and all the best. I'm not able to solve. Yes, Ankit, I'm doing logical reasoning on Thursday morning. Okay, for BitSat. Yes. Okay, so I'll tell you what. Since this is a loop, closed loop, what is the net force on a loop? I just gave you the theorem. It is 0, right? I just gave you. It is 0. So the force acting on the loop is force acting on AC plus force acting on BC plus force acting on CA. This entire thing is 0. Now we need to find the force acting on AC. Okay, so the force acting on AC plus force acting on BC is given to be F. So I'll just replace it with F. Now I'll tell you what is the best part. The magnetic field is acting along AB. This is the direction of magnetic field. Don't you see, this force will now become 0 because L cross B will be 0. Length vector and magnetic field vector will be 0 because theta is 0 between length and B. So this term will vanish, and hence the force acting on AC, just shift it on the other side, it will become minus F vector, and hence option B is correct. That's how it works. Interesting question. You have to use vector algebra, and you have to also use the theorem which I just taught you. Net force on a loop in a uniform field is 0, and also use basic common sense and geometry. That's it. You will land up with answer B. Very good question coming, which just came up on your screen. Next question that's on your screen is this one. Beautiful question. Job Cherian, my age. My God, it's very difficult, man. But I can just tell you one thing. जितना तुम्हारा उम्र है उतना शायद मेरा experience होगा. That means whatever your age is, probably that's my experience. Okay. Chalo, let's get going, guys. Let's see how many of you can do that. Okay. Made a silly mistake. No problem, Yashaswani, happens. That's why I gave you these questions so that you can work on these mistakes. It's okay to make mistakes out here. Pramesh saying B. Interesting. Siddheshwar saying 2 pi BIR. Okay, I'll tell you what. First of all, understand why is there tension in the loop. See, if you take any curved part, okay, which is carrying some current and magnetic field is inside, if you do L cross B, okay, IL cross B, I think the direction of the current should have been probably other way around. Okay, this direction is giving the forces inside. L cross B is coming out to be inside. Okay, so I'm just changing the direction of the current because otherwise it will not be under tension. Okay, so current is going like this, magnetic field is inside. So if you do L cross B, you will see that this ILB force will be outward. It's like you are pulling it outward from every side. You are pulling it from every side. So if you pull a ring or a loop from every side, it will stretch, it will expand. That's why what will happen is that there will be some tension because it is trying to increase its length. You are pulling it from here, 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 here. Imagine 10-15 people are holding their hands and playing Ringa Ringa Roses. I am holding one person's hand, I am holding another person's hand here. Somebody is pulling us apart. Obviously there will be tension in our hands. Exactly. So that's the reason why there is tension in the loop. Now I'll do a beautiful way to solve it. I'll use a beautiful way to solve this question, and that is I'll just take half of the loop. This is basically semicircle. Yeah, this is a semicircle. Now once I take a semicircle, you will see that the forces acting on them are, number one, a tension here and a tension here. Remember, these are the ends of that semicircle. I'm not taking the whole loop because if I take the whole loop, tension will become internal force. Then how will I find tension if it becomes internal? So that's why I took some part of the loop, and for convenience sake I took semicircle. So it becomes external force. Tension is acting like this. Now guess what? The force due to magnetic field on a curved wire is something which you have just figured out, and it is nothing but I L effective into B. And since this is at rest, shouldn't I L effective into B be equal to T plus T? Both of them should be equal. Now what is the effective length, guys? I hope you can see that. This is the effective length, which is 2R. 2R is the effective length. So it will become I into 2R into B is equal to 2T. Therefore T is equal to, because 2 gets cancelled, IRB. No need of integration or derivatives. You will just get it as IRB, which is option A. That's it. Beautiful. Thank you, Pardeep, so much. Okay. So Siddheshwar, which part you did not understand, please let me know. I'll help you out. The whole idea is that if you have a loop which carries current, okay, it will experience force outwards because of IL cross B. Because of this IL cross B force, it will experience force outwards. Now this outward force has basically caused some tension within that wire or that loop. So there is some tension, and that tension is same throughout. It's same, obviously by symmetry, everywhere it is same. So to figure that out, I divided the loop into two halves so that the tension becomes external force. I have just drawn the free body diagram. Tension, tension, okay, and magnetic force. So the curved wire can be replaced with the straight wire. Just equate the forces, you get the answer. Yeah, I hope this is clear. Okay, so let's get going to the next one. Job, Acharian, are you making a profile for matrimony website? You are asking everything. Sir, what is your experience? Sir, which food do you eat? Sir, do you know cooking? Sir, what is your job? Sir, what is your salary? Sir, what is your 10th and 12th percentage? Sir, how much can you run? Sir, what kind of movies do you watch? Sir, what kind of... I will answer everything in some casual session maybe. Right now, by the way, I'm not interested in matrimony website, okay? So hold on, I know you are very much interested to know everything about me. Someday, probably not today, when we have a casual session, make a list of all these questions and bombard me. I will answer all of that. Okay. Sir, what not force downwards cause tension? PL, this is in the horizontal plane. We are ignoring gravity. Gravity is not to be accounted for here. Yes, probably someday coffee with Shreyas. Okay. Okay. Yes, you can do that, Aditya. Yep, you can do that. But I wanted you guys to see the concept of replacing the curved wire with a straight wire, because that's the whole joy of, teaching you that concept. Which is better, JEE Mains or JEE Advanced? Kukop Sukte, that's a very weird question. I mean, what do you mean by that? Both of them are for different purposes. JEE Mains is for NITs, triple ITs. JEE Advanced is for IST, IIT and ISER and kind of institutes. So two different things. Okay, cool. By the way, if you want the entire lecture problems with summary and PYQ and low to high difficulty level problems, if you are lacking practice, if you want a book, I'll tell you the best book to use is the Tattva material which is given by Vedantu. So you will get the soft copy as well as the hard copy if you are in the long term batches, and every topic or a unit has a separate book, like magnetism separate and then electrostatics etc. separate and 11th standard separate and all of that. So I feel you should practice from this book. Number one, the use is the advantage is you don't have to follow multiple books. Everything has been compiled into one book. So the number of reference books that you need to use becomes drastically less. Variety of questions is good. PYQ is also there. Simple questions are also there. Hard questions are also there. So that's something which you should look for. Yes, Aryan, you need that easy questions, bacha, because understand there are a lot of students who need that confidence. Lot of time people ask, sir, I don't know when to use which formula. So that's when you start solving level 1. Sir, I don't know how to begin a question. Start with level 1. You will get confidence. Then you go to level 2. So level 1 is warm up, confidence builder exercise. Then comes level 2 and then you have exercise 3 and exercise 4. That's how it is. Okay. So both Aditya, HC Verma as well as Tattva, you can solve both together. In fact, you can solve mainly HC Verma short answer and objective questions and then go to Tattva. You can skip the exercises questions a lot then. Okay, chalo. Welcome, please don't spam bacha. Now let's talk about magnetic dipole moment. Okay. Ruchita, yes bacha, I have qualified. I gave my JEE Advance in 2005 and I cleared my JEE Advance also. Okay, I almost got like full marks in physics. Okay, can we get back to studies? Bahut ho gaya mera biodata. I hope you can make a very good profile out of me. You can put up everything that you have just gathered in this brief amount of time. Bahut zyada information ho gaya. Let's focus on the session. Yeah, please. Okay, so magnetic dipole moment. Now remember electric dipole moment. Positive charge, negative charge, separated by distance. Charge into length is electric dipole moment. Correct? Charge into length is electric dipole moment, Q into L. I have given you that. Same way, magnet produces magnetic field and there are two poles separated by a distance. It will also have a magnetic dipole moment. Now, what else behaves like a magnet? It's very simple. Electromagnet. A wire carrying current. Everybody has built an electromagnet or seen it at some point of their childhood. You just basically, wind some loops and you get an electromagnet. So a loop carrying current has similar field lines just like a bar magnet. So if this has a dipole moment, even this has a dipole moment, because you can see their behavior is similar or same. So electromagnet or permanent magnet, doesn't matter, they all have dipole moment. It's a vector quantity. What's the direction of the dipole moment? It's always from the negative to the positive charge. So for a permanent magnet, it's from the negative, which is the south pole, to the positive, that's the north pole. That means towards your right side. Everybody clear? So the dipole moment is always from the negative to the positive, south to the north, that side. For an electromagnet, very easy. Everybody has the right hand. Come on, curl your fingers. How? In the direction of current. How is the current going? Like this. You can see the current is going like this. Curl your fingers. It beautifully curls like this. Where is your thumb pointing? That way. So that's the direction of the magnetic dipole moment. That's how it is. Same like electrostatics. Yeah, exactly. ABCD, I do not use 2L as the separation distance. I use L as the separation distance because that number 2 already causes enough confusion in a lot of young minds. So I prefer not to use that number 2. I already defined the length as the total distance, not the half distance. Alright. Now, if you have a loop carrying current, I just told you about the direction. Curl your fingers in the direction of current. The thumb points in the direction of magnetic dipole moment. And the formula for magnetic dipole moment is, do you know the National Investigation Agency which India has? They investigate on very high profile matters. Yeah, they investigate very, very complex matters and some terrorist activities or some threats, etc. National Investigation Agency, NIA. So remember that. Just like America has CIA, you would have seen in Hollywood movies, CIA is doing that. CIA has hidden this. See, I hope CIA is not hearing to whatever I'm saying. CIA, sorry man, I didn't say anything. Okay, I just took your name. I didn't do anything. Okay, please don't bookmark this video and do something against this video. Okay, I'm just, CIA is very good. Hey, yo CIA rocks. Okay, so similarly you have NIA, that's for India, National Investigation Agency. So that's the way to remember this. I is for current, N is for turns. Each turn will have a magnetic moment. 2 turns twice, 3 turns thrice, N turns N times. A is the area. Big area, it will have large magnetic moment. Unit is very easy. N does not have unit. I is ampere, area is meter square. So that's why ampere meter square, as simple as that. Okay, so that's how we go. All right, capital M. Now some books use, instead of this, they use mu. Now I'm not particularly, okay with this symbol, because this mu might lead to even more confusion, because that mu is already used for permeability, relative permeability, God knows what. So I don't like that. I like M, so I'm going to use the symbol capital M. Some books use capital mu. I don't like it. Although mu looks like M if you write it in freehand. Anyways, going ahead to a question. Okay, thank you Pardeep so much. Can you use BM? It's up to you, whatever symbol you want. Yeah, whatever symbol you want, but just use a consistent symbol and don't get confused, that's all. Let's see whether you can solve this question coming up on your screen. This was asked in JEE 2012. That's when the world was supposed to end, but it didn't. And we are, almost like what, 9 years? Yeah, 9 years after 2012, the world hasn't ended. 2012 people, fools. And the world is not ending even now. Okay, in spite of COVID. KCT is a subset bacha of JEE Mains, so it automatically gets covered. Glad Vidrush, okay. Zarka mechanical properties is already covered in Flash series. You can watch the replays, or if you want to wait, then wait for some more time. It will take few more months for me to reach mechanical properties, but you can watch the replay of Flash series till then. Okay, let's see. Option B, A. People are confused. Some are saying A, some are saying B. Look at this. This is a fancy drawing. Current is going like that. This is A, this is A, this is A. Semicircles. Think about it. What's the magnetic moment? You just have to calculate the area. Looks like my janta is thoda sa aisa serious type. They don't understand jokes, I feel. Very few people. See, chemistry lover PhD laughed. Munna bhai also laughed. And who else was there? I don't know. Okay. Baba Lamborghini. Okay. Oh, Aishwarya finally understood something. Okay. Thank God. Thank God. Please laugh. Okay. Then I feel that you guys get my sarcasm and my sense of humor. Anyways. Alright. Alright. Let's get going. And the magnetic moment, all you need to do is find the area. Let's count. I have a square. So cool. I have a square. And then I have 4 semicircles. 4 semicircles is 2 circles. Right? Everybody knows this. Not a big deal. I have 4 semicircles. Beautiful. So, area is for the semicircle twice the area of a circle. area of a circle is pi r square, but be careful, the radius is a by 2. This length is a, so it is a by 2 square. So this will be 2 square is 4, 2 gone, 1 2 remains, so pi a square by 2. That's the area of the circular part. Now the area of the square part, that's just side square, so a square. So magnetic moment, n is 1, I, what is I is I guess, oh I is I, yes, into area, which is a square plus pi a square by 2. That's it. So a square is common, and 1 plus pi by 2, I guess. Where is it? 1 plus pi by 2 a square. And is it in k cap? Yes, it is. You bet. I mean, look at that. Current is going like this. Curl your fingers. It's going like this. Anti-clockwise. It's going anti-clockwise. Curl your fingers anti-clockwise. Right hand. Please make sure you're using a right hand. See, where is the thumb coming? Towards you. What is this direction? Obviously, it's k cap direction. So that's why the answer is B, B, B. Yeah, very good. A lot of you are correct. 10 CBSE question of finding area. Believe me, this came in JEE 2012. I think the examiner thought the world is going to end. Let's just give easy questions to the kids. I don't know. That's what probably he thought. But the world didn't end, and a lot of kids passed. And there we are. Okay. The charged particle Q is moving in a circle of radius r, uniform speed omega. The associated magnetic moment m is given by. Also find the angular momentum of it. Very good, Yashaswini. Hi, JEE Mains, welcome. All right. Okay, come on, my warriors. Figure this out. So, I'll tell you what is exactly happening in this question. So, you have a charge Q and it is rotating. Okay, it's rotating with angular speed omega. So, the question is, what is the angular, what is the magnetic moment? And the question is also to find the, angular momentum. I'll tell you what, a charge which is flowing is like current flowing. Both are similar. Charge is moving, that's why current is flowing in that circular loop. So now things are easy. So what's the current, guys? Current is how much charge flows upon how much time it takes to flow. So in one period, if you wait, let's say I wait, over here I'm waiting. Oh, there comes the charge. It goes, zoop, and it goes every t seconds, one time period. So the charge which goes is Q and it takes time period t. Now we all know the formula for time period. So that's 2 pi divided by omega. So omega goes upstairs. That's the current which flows through the wire. Now from this, I have my magnetic moment. So current carrying loop, one loop, okay. I is this Q omega by 2 pi into area was the radius r, so pi r square. So all I have done is NIA, that's all. So NIA, I get the answer. So pi by, so Q omega r square divided by 2, that's the magnetic dipole moment. That's the answer. Excellent. I am coming to that, Aditya. I'm just coming to that. Yes, I'm coming to that. What do I think about JEE 2022? What do you mean by that? Gokula, should I write an essay? I don't know. What is the question? What do you think about JEE 2022? This is like an essay kind of question. Like, what do you think about climate change? What do you think about global warming? I don't know. Okay, so here we go. Next question. L is I omega, angular momentum. It's a charge, point mass. So moment of inertia is mr square into omega. That's the value of L. Now guess what, guys? Oh no, 2022 will not probably get delayed. I don't know. Yeah, we don't know. Too early to guess. Don't worry, break your head. The current students only don't know when is their exam. You guys are going to write it after one more year. You don't even know what versions of coronavirus are going to come. Till now we have come till alpha, beta, gamma, delta. Probably we might just run out of alphabets and Greek symbols. Probably we might just invent a new language, because we just ran out of alpha, beta, gamma, delta, zeta, and we need more variants, right? Probably, who knows? So learning that language might take time. Probably JEE might get postponed. We don't know what's going to happen. So too early, just study, man. Okay, cool. Let's get going. Now just divide both of them, m by l. Just divide both of them. M by L, just divide that. You'll get Q omega R square by 2 divided by M R square omega. Now the best part, omega by R square by. So you will have Q by 2M, and this is something which you should remember. M by L is Q by 2M, always works. M by L, magnetic moment by angular momentum, is Q by 2M. Standard result, not just for a point charge, by the way, we just got this. It works for everything. Everything, understand that. Yeah. Well, Akash, you can just ping me later on. I'll tell you how to actually do self-study later on. So, it works for any rigid body which is charged and rotating. Magnetic moment by angular momentum is Q by 2M. Use this property. Let's see. Yep. Let's see. Yes, the charge and mass distribution should be of the same variation. The way in which mass varies, the same way the charge should vary, only then it works. Yep, makes sense. Let's see whether you can get this. And there we have a disk which is rotating and it is charged. And the question is, what is the magnetic moment? Now, the lengthy way of doing this is, you divide the disk into small charges, find the magnetic moment for each charge, and then integrate, and then find it for a ring, and then find it for a disk. That's the lengthy way of solving the question. The better way is using this concept of M by L. So M by L is Q by 2M. Just use this. So M will be L, which is I omega, into Q by 2M. So I for a disk is M R square by 2. Omega is omega, Q by 2M. MM goes, and you will be just left with Q omega R square by 2 2s are 4. That's the final answer. In the final exam, you won't have so much time to sit and integrate. Just use this. That's it. Done. Yep. Vinkesh, I can talk about cyclotron some other day, but cyclotron as a separate topic is not there. Okay? It's just like a fancy thing which you can study, but as such, there is no such question on cyclotron. Okay? But we'll do it some other day, just for the fun of it. Okay. Let's get going to the next one. Yes, chemistry lover, I will do that. Yep. Mohammad Rahil Bache, looks like you have not yet seen the upcoming lectures. Watch the upcoming lectures. You have not seen Telegram post. You have not seen community post. Mohammad, just go and watch it, man. It's all there. Tomorrow I have a mock test for BitSat and JEE Mains. Just check it out. Okay. Let's get going. Now, torque on a loop in magnetic field. Torque on a loop in a magnetic field. Now see guys, it's very simple. If a wire carrying current can experience force, obviously these forces can produce a torque. Now, what is the net force acting on a loop which is placed in a magnetic field which is uniform? Answer in the chat box. What's the net force? What's the net force acting on a loop placed in a magnetic field? Come on. 0, right? Very good. But torque may not be 0. It may be or it may not be. And look at this. Imagine there is a loop. Okay, just imagine there is a loop. And let's say it's carrying some current. Okay, let's say it's carrying some current. Now, current is going like this. Now, this is actually in 3D, but I have shown it in 2D. So, there might be some amount of visualization that is required from your end. Because the current is going like this, use your right hand fingers, call it like this. You will see the thumb popping out this way. So, that's the magnetic dipole moment, that way. Now, this is 3D, right? Let's look at it from the side. If I look at it from the side, I'll probably just see this edge of the loop. If I see it from here, okay, I'm seeing it from here. So I'm just going to see this edge of the loop. I'm going to see this magnetic dipole moment, and I'm also going to see this magnetic field like this, making angle theta over here. Cool? Great. Now, here is the thing. Let's try to figure out what are the forces on each element. Let's try to see. Observe this carefully. Okay? Okay, look at probably this element. Now actually this is in 3D. Strictly speaking, this element is here. This element is here, like that, inside, behind. Length is here. Magnetic field is there. Magnetic field is exactly there. So do L cross B. I'm using my right hand. L cross B. If I do it, it comes exactly upwards. So the force is here. That's the force. That's it. It's coming this way. Look at that. See if you can visualize it. Yep. Now, what happens when the torque is 0? Ankit, we are coming to all the situations. Hold on. Now, the thing is, similarly, try to think for this length. This element over here is inside. It's going inside the plane of the board. Because I'm seeing it from here, I'll see it go inside. Okay? Magnetic field is that way. Magnetic field is that way. L cross B, it's downwards. Look at that. L cross B will be downwards. So, for that, L cross B will be here. Yeah, that's how it is. Great. Now, similarly, you can also find the forces on these two sides. I will leave it up to you to figure it out, what the direction is. But let me tell you, the force will come out like this. Yes, the force will come out like this. And I'll give you also a trick. This will help you so many times in solving problems. Hint is, if you find the direction of force on any one element, and let's say it comes outwards, on all the elements it will always come outwards. Even on one element, if it comes inwards, on all the elements it will come inwards. So you don't have to break your head for every single part of the loop. That's a very interesting trick. How many of you knew this from before? And if you did not know it, please put a no in the chat box. Yeah, that will be very, very helpful. Jayant Bachcha, I'm taking classes every day. I don't know whether you are seeing it or no. I'm taking classes every day. Just have a look at the past videos, okay? Cool. And now, here is the thing, Ankit, I'll tell you once more. If you have any loop like this, let's say, any one element you find the force to be this way, then on every element it will be outwards. If on any one element, let's say it is inwards, then on all the elements it will be inwards. That is the point that I just made. So that is easy way to avoid multiple right hand thumb rules. Now, if this much is understood, let's see which of these forces are creating torque. Look at that, these two forces, one of them is here and the other one is inside. I don't think they will produce torque. So no torque because of them. These two forces are definitely not giving torque because both of them are collinear forces. Remember, if one force is here, another force is here, they will not produce torque. But one force is here, one force is here, then yes, they will produce a couple kind of torque. Collinear forces never produce torque. When the forces are separated by certain distance, then obviously they will produce torque. Okay, that's how it works. Jayant Bachcha, I can't take Pathfinder classes every day. I have to cater to other students also. Remember, there are 2021, 2022, 2023 students. So I have to distribute my time. Number two, I am teaching on Pro plus Sunday is a holiday. So I understand, obviously, in a week, I can only teach 2 or 3 days, not more than that. Okay, for each standard. Getting ahead. Here, what will happen is, if you extend this force, you will see this is the separation distance. Separation between the forces, and these two forces are going to produce torque, which produce torque. I hope you can see that. So these are the two forces which are producing torque, and from this I can actually figure out how much is the torque. Remember, the torque due to a couple force is nothing but the separation the separation distance multiplied by any one of the force. This is a standard formula from rotation. I hope this is clear. Yes, I hope this is clear. Yes, angular SHM, everything can be performed. Yes, we'll be doing those kind of questions in advanced session tomorrow at 7:30. Okay, so torque due to any couple, this is a rotational concept, is the distance of separation between those two forces into any one of the force. So what's the separation between them? Well, that's not difficult to figure out. If let's say this length is L, let's say this length is H, example. So if this is L, this is L. Now if this is L, think about it, this is theta, okay, this is also theta, okay, I don't know whether you can see that, okay, this is L, this is L, this is my separation distance which I just told you, this is my separation distance which I just told you, okay, this is theta, this is 90 minus theta, this is 90 minus theta, so this is also theta, this is 90 minus theta. So this distance will be L sine theta, as simple as that. This is L, this is theta, this is 90 minus theta, this is 90 minus theta, so this is also 90 minus theta, so this is theta. Now this is L, obviously this is L sine theta. So hence this separation will be L sine theta multiplied by that force. What will that force be? Think about it. What will be that force be? That force will be I, L is H into B. I, L, B. Length is itself H. Keep that in mind. So this will be I, H, B. Now rearrange them. Just rearrange them. So it will become I, L, H on one side, B other side, and then you also have sine theta over here. What is I, L, H? Current into length into H. That's L into H is area. So that's nothing but N IA, so which is magnetic moment, into B into sine theta. So that's your torque. That's how it is derived. So the torque acting on a loop is nothing but, you know, MB sine theta. M is the magnetic moment, B is the magnetic field, yeah, and sine theta, where theta is the angle between the magnetic moment and the magnetic field. As simple as that. Okay, is that clear? Very good, very good. Yes. So M already includes N. Be careful. N is included in that M. So you don't have to separately multiply it with N. So any loop which carries current placed in a magnetic field will experience torque, and that torque will be given by M cross B. Yes, you can write it as M cross B. Yep, that's how it is. Very, very interesting. All right. So now probably you will get a hint how DC motors work. How will a motor work? Because of this torque. When there is current carrying wire in the loop, understand what will happen. There are magnets. Yes, this is like a motor, guys. When that current passes, that loop will rotate because of that torque. That's exactly how an electric motor works, because of this torque. Okay, M cross B, keep this in mind. Okay, I have put up the derivation for you in case you need it, whatever I did over there, but still it's there. Now, going to the energy part. The true meaning of a loop, Ashutosh, is basically some geometry, a curve which has no end and no start. That's basically the meaning of a loop. Okay, there is no start and no end. It's a curve, continuous curve, which has no discontinuities anywhere. That's the meaning of a loop. Now, because there is a torque, probably there is also energy. Yes, there is also energy associated with the loop, and that energy is called as the potential energy of that loop, which is placed inside the magnetic field. You will see, if you place the loop, let's say like this, then you place the loop like this, then you place the loop like this, okay, then you place the loop like this, you place the loop like this, and you place the loop like this. Every time, let's say the magnetic field was in this direction, you will see, you will have to do work to change the orientation of the loop, because there is a torque acting on it. That torque will make sure that you do some work in rotating that loop. And that means if you leave that loop somewhere else, if you just leave it, it will automatically flip because of that torque. That means it has ability to do some work. It's like a spring which is twisted. The torque, because of the magnetic field, will rotate it. It's as if, you know, there is a torque by a spring, which is like a potential energy which is stored inside it. So that's why a loop which is placed inside a magnetic field also has some potential energy, because it has ability to do work because of that torque. That's how it is. Now, the formula for that potential energy is very simple. But before going ahead, let me tell you the definition where the potential energy is assumed zero. If the magnetic moment of that loop is perpendicular to the magnetic field, then this is assumed as the zero energy. The potential energy is assumed to be zero. This is called as the zero reference energy. All energies are measured with respect to this. They are measured with respect to this state. Remember, even in gravity, we used to always assume this is zero potential energy. Acha, this is mgh. Acha, this is minus mgh. You always need a zero reference line. Same way, the zero reference over here is when the loop's magnetic moment is perpendicular to B, and that's what you assume it as zero reference. Yeah, and then the formula for that comes out to be U is equal to negative m dot B. This minus sign is very, very important. You can also write it as minus mb cos theta. This is the formula. Minus m dot, it's an energy, so scalar product. Yep, minus sign. Be careful. Is that clear? Everybody understood? Shall we go to some questions quickly? Shall we solve some questions, guys? Yep. This is the energy which is induced because of the torque produced by the current which is carried in the loop Vulcan. Yeah. Let's go to some questions. Okay. So all the derivation, if you want the derivation for the energy, I've put it for you just in case you need it. Okay. Chalo, let's get going to some questions. Yep. Here is a question. There is a coil of 100 turns and diameter is 20 centimeter. Current is 0.5 ampere. It has to be turned in a magnetic field of 2 Teslas from a position where the normal to the plane makes 0 with the field till it becomes 180. What amount of work do you need? Let's see. Okay, come on. If you did not understand the question, no problem. I'll just draw the situation for you. There is a loop and the magnetic moment initially makes 0 degrees with the field. I want to rotate it. Yep, I want to rotate it. Till the time, you know, that magnetic moment, till the time the magnetic moment makes 180 degrees with the field. So this is 180 degrees. How much work you need to do? As simple as that. Okay, let's see whether you can do this. And the logic behind this question is, you know, very simple. Whatever work you do on a system will always go in changing its energy. Now, because the loop was at rest and you rotated it and kept it at again 180 degrees. So whatever work you did went in changing the potential energy or the orientation of that coil. So kinetic energy did not change. You just have, it was at rest, you just flipped it. That's it. So you have done some work. That work done externally is gone in changing the potential energy, which is final energy minus initial energy. So final is when it is at 180, initial is when it is at 0 degree. Okay. Now, what's the formula for a potential energy? Minus m dot b. Okay, so minus m b cos 180. Okay, minus m b cos 0. Okay. Now cos 180 is minus 1. Minus into minus is plus 1. So it will just become mb. Minus into cos 0. Cos 0 is 1. Minus minus becomes plus. So it will become again mb. So it will just become 2 times of mb. Acha. Now you just have to substitute the values. Remember, m is nothing but NIA. Now just start substituting the values. What's the value of N? There are 100 turns. Okay. I was the value of current. It's 0.5. Okay. Into area. It's pi r square. So pi into 0.1 meters square. Into magnetic field. What is it? It's 2 Tesla. Just put it over here and I think you're going to get the answer out here very easily. You can use the method which I have taught you so many times. Powers of 10 should be ignored and just do it normally. 2 into 5 is 10 and 10 into 2 is 20. So answer will have 2 pi something and that means it should be B. Ignore the powers of 10. You can do that. Yes, option B. That's how it is. Beautiful. Okay. So you just had to visualize the question. The words are difficult, but trust me, as such it is not so difficult. Now, thank you Adarsh. Welcome aboard. Hi Sanjay. Yes. Yes Sonu. Answer is B. Yes Aishwarya. Yes Bismita. Very good. Very good Chinmay. Very good. Excellent. Now let's try to fill up this table because a lot of people get confused over here. And this is one of the most important things. Whenever you have a loop, there are certain orientations where the loop will be in equilibrium. It will experience maximum torque. It will have minimum energy. And those equilibriums could be stable or unstable. So very easy way to remember this table. Look at this. First situation, field is here and the magnetic dipole moment is also in the same direction. So the angle in this situation is 0 degree. The loop, okay, the loop which was carrying current, okay, is such that the magnetic dipole moment is here. Angle between M and field is 0. In the second situation, the loop is like this. The magnetic dipole moment is here. It's making angle 90 degrees. In the third situation, the current in the loop is such that the magnetic dipole moment is 180 degrees with the field. Now let's try to fill this table out here. Now look at this. First situation. Remember, torque is nothing but M cross B, which is MB sine theta. Theta is 0, so that means torque is also 0. That's the reason why this has 0 as the answer. Energy, it's minus MB, which means it's minus MB cos theta. Theta is 0, cos 0 is 1, so answer is minus MB. Is that clear? Okay. Let's go ahead. In the next situation, the torque will be MB sine 90. Sine 90 is 1, so it will be just MB. Cool. What about energy? Oh, if you remember, we had defined this energy state as 0 energy. Even if you use the formula MB cos 90, the answer will be 0. Great. Similarly, go to this situation. MB sine theta will give you torque. Theta is 180. Sine of 180 is 0, so the torque is 0. Similarly, go over here. Energy is minus MB cos 180. Cos 180 is minus 1. Minus into minus is plus, so it's just going to give you MB. Now don't you see, this negative value is the least value and this positive value is maximum value because this is plus MB. Don't you see, over here the torque is 0 and here also it is 0. That means these are the two situations when it will be in equilibrium. This is also equilibrium, this is also equilibrium, but the catch is this equilibrium is stable. Reason, if you take that loop and displace it slightly with the field, okay, if you displace it slightly with the field, you will see there will be a restoring torque. There will be a restoring torque which will bring it back to its original position. So if by chance you rotate it, you will see it will come back to its original position. If you rotate it like this, it will again try to come back to its original position. That's the reason why I'm calling it to be stable equilibrium. Similarly, over here in the last situation, when the torque is 0, understand the magnetic moment makes a very large angle with the field. Okay, it makes a very large angle with the field. Even if you displace it slightly, the torque will push it on the other side. So earlier M was here. If you even displace it slightly, the torque is going to push it that way. It's going to push it away from that particular position. So that's why this equilibrium is unstable in nature. This is unstable. It does not like to be here. But if you leave it carefully here, it will stay there. Small disturbances will immediately flip it to the other side. That's what will happen. And this one, a lot of people think this is neutral equilibrium. No, this is not an equilibrium. Reason for that? The torque is there. In fact, the torque is maximum. Remember, the essential condition for equilibrium is that, for any kind of equilibrium to happen, the torque should be 0, force should be 0. Force though anyways was 0. The only problem is that, the torque should also be 0. Only then it will be true equilibrium, and that only happens in these two situations, not otherwise. I hope this is clear. Alright, so very, very important. I have filled it up for you, don't worry. Okay, so it will be coming up in your PDFs so that you can revise through this. Last question for tonight, and here it comes. A current which carries a current carrying rectangular coil is placed in a uniform magnetic field in which orientation the coil will not tend to rotate. Beautiful, based on exactly the previous concept on the previous slide. Come on, my warriors, think about it. All right. In which orientation the coil will not tend to rotate? The magnetic field is parallel, the magnetic field is perpendicular, magnetic field is at 45 degrees. Anyways, in all the orientations. A lot of people saying A. Well, all of you are wrong. Ankit is correct, looks like. Yes, it's option B. Be careful. When it does not tend to rotate means torque is 0. That means theta is 0 or 180. That means M vector and B vector should be in the same direction. Don't you see the magnetic field is perpendicular to the coil? The magnetic field is perpendicular to the coil, but the moment makes 0 degree. A lot of people get confused over here. A lot of people get confused. Understand, moment makes 0 degree. The coil makes perpendicular because moment itself is perpendicular to the coil, bachalo. Be careful. Yes, Karniti, it will be useful. And if you want to know more about it, well, let me tell you, actually speaking, any amount of material is not enough, and any amount of material is also enough for preparation of JEE. I'll tell you why. Before that, leave your comments for these two homework questions in the comment section. I will be checking how many of you are going to do the homework really quick. This is your second question for homework. Don't worry, you can replay the session anytime. Now, see guys, why just not YouTube, or why a coaching center? See, on YouTube, yes, you're going to get good material, you're going to get quality content. We are going to be here always for you. It's not like we are going to run away and just be teaching on the paid platform. No, we'll be always there. But the thing is, you will not have that discipline of coming every day. A lot of people come one day, some of you don't come one day. Some of you probably have not even subscribed to test series. Some of you have a lot of backlog of 11th standard portion. You don't even know where you stand at national level. Correct? You don't even have proper guidance or proper books for studies. You don't have somebody constantly to solve your doubts. So that's why you need coaching. Only YouTube will work, yes, but then you need some proper mentor who is there with you. You need that self-motivation and the discipline every day. And best thing, like some of you are doing out here, attending the pro classes plus, attending the YouTube classes, the combination, the two inputs that you get, the problems done here, practice done here, that combination is the best combination actually. So another thing which happens in Vedantu is our classes are there in both the mediums. So you have the option to join an English batch or Hindi batch, up to you. And you don't have to worry about anything, guys. I mean, right from KVPY, boards, any exam that you can think of, you don't have to pay anything extra. We have 3 kinds of packages: light, classic and plus. In the light version, you get everything that I just told you, including the classes. And Asif, the demo material for Vedantu Tattva, I'll tell you something. Well, it's very simple. Whatever questions we have been doing, some of them are from Tattva module. Okay, and if you want the demo, the best thing you can do is join the subscription for 1 month. Okay, join it for 1 month, and you get the Tattva material, soft copy. And if you like it, good. If you don't like it, no problem, don't continue. So that's the best way to take a demo. And guess what? The demo prices are very cheap, 3,000 per month. If you want the doubt solving or the plus version, then you can go for these plans where you get personal mentor, or you can also get the doubt solving on the app. See, this is a important thing. If you want somebody to solve your doubts instantaneously from morning till night, you can go for this version. But if you want to try it for 1 month, please go ahead, try it out, any of the packages, and you can use my coupon code SHHPRO so that you get 10% off. Yep. So that's what you can do. Alright, Asif, bye bye guys, take care, and do check out the link which is there in the description box below. The link is just there over here. So when you go down on any video, you will see there is a link to join the pro subscription. All the details I just mentioned is out here. You can see. You can even join for 12 months using EMI option. That is also there for all of you. Alright, so Anand, if any problem happens, let me know. Okay, if you use my coupon code, let me tell you one thing. Any problem happens, just tell me one thing. I'll make sure that problem will get resolved instantaneously. Okay, just tag me over there. Okay, cool. Yeah, just try out the demo one. So it's for 1 month, and do not forget to use the coupon code so that you get 10% off. And any problem happens, I can get involved out there. So that's the advantage. So all the things are mentioned in the description link. Check it out. I would be really happy to do that. All right. So bye bye guys. Thank you very much. Hasta la vista. This was Shreyas here, your physics master teacher.